The objective of this lesson is to represent multiplication using an array and to draw the representation using the box, line, dot method. Prior to this lesson, students have practiced representing multiplication using arrays and open area models. These models help students visualize how a multiplication problem can be broken down into its parts using the distributive property. The goal is to move students from conceptual to more efficient methods of how multiplication works. In this lesson, array is used when representing factors by drawing each individual rod or unit to indicate partial products. The term partial product means part of the answer to a multiplication problem. Partial products are added together to obtain the total answer. First, let's explain the box, line, dot method to represent place value, used in lesson 3.3. When multiplying one digit by a two-digit number, the dot stands for 1, the line represents 10, and the box represents 100. Let's solve the following problem using an array. The store has 14 boxes of glasses. Each box holds 12 glasses. How many glasses does the store have altogether? 14 times 12. First, draw an array bar and write the two factors on the outside of the bar by decomposing both numbers. Place the 14 as 1 10 and 4 ones vertically along the left side of the array bar as the number of rows. The 12 as 1 10 and 2 ones horizontally along the top of the array bar as the number of columns. Fill inside the array by multiplying the rows by the columns. Look at the top left corner of the array and notice it represents 10 times 10. Draw in a box to represent 100. The top right corner represents 10 times 2. Draw two lines vertically to represent 20. In the bottom left corner, multiply 4 dots times 110 to represent 40. Draw 4 10 lines horizontally to equal 40. Finally, on the bottom left, 4 dots times the 2 dots on the top right for a total of 8 dots. Draw 4 rows of 2 dots to represent 8 in the bottom right corner to complete the array. The partial products are now represented in the array. We have 100, 6 10s, and 8 ones. 100 plus 60 plus 8 equals 168. Let's try another problem. If there are 22 students in your class and you want each person to receive 13 pieces of candy, how many pieces of candy will you need? 22 times 13. Draw an array bar. First, decompose 22 into 10 plus 10 plus 2 and 13 into 10 plus 3. Write the decomposed numbers on the outside of the array bar. On the left, draw the lines and dots to represent 10, 10, and 2 ones. On the top of the bar, draw lines and dots to represent 10 and 3 ones. Fill inside the array by multiplying the rows by the columns. At the top left corner of the array, notice the lines that represent a 10 times 10. These are the dimensions of a hundreds box. Draw in the 2 boxes vertically to represent 2 100s. At the upper right corner, it has 3 dots times 2 10 lines to equal 60. Draw the 2 sets of 3 lines vertically to represent 60. At the bottom left, there are 2 dots times 1 10 line above, which equals 20. 2 10 horizontal lines fit here to represent 20. Finally, on the bottom right, 2 dots times the 3 dots on the top right are multiplied together for a total of 6 dots. 2 rows of 3 equals 6 dots in the bottom right to complete the array. Now the partial products are represented. There are 2 hundredths, 8 tens, and 6 ones. 200 plus 80 plus 6 equals 286. Students learn to understand how the array relates to multiplication. This method gives a visual representation of the problem. To answer our problem, 22 students with 13 pieces of candy each equals 286 pieces of candy. The objective of this lesson was to represent multiplication using an array and to draw the representation using the box, line, dot method.